Hi, everybody. I get the feeling the last session was very energizing. People are still chatting about it a lot. But we're going to dive into the next exciting, energizing session now. So I want to welcome you all. Do I need to slouch or can you hear me? Okay, great. Thank you. Thank you so much for coming to the Safety, Sanitation, Pest, and Pathogen session. And I've been thinking today about, and yesterday, how many of these sessions are like everybody who's here at this conference doing what they do in all our various ways because of caring for the land. And this session is really about being careful while we do that. And I've seen examples already in presentations today where not knowing things and maybe not being careful in the past has had ramifications. So I'm super excited you guys are all here to learn what we have our speakers here to share today. And the title is very broad. There's lots of different kinds of pests and pathogens. But everybody who's speaking today is speaking about Phytophthora. And many of us in the room have been, admittedly, pretty Phytophthora focused for the last 10 years or so guilty. But it's a good place for us to be. Phytophthora translates to plant destroyers. Everybody here loves plants, so it's a good place to start. And it also, the concepts and principles translate to other pests and pathogens, as well as to just a general do no harm principle in what we're doing. So I want to make sure I hit everything there. Yes. Okay, so we have set up our session today, roughly 15-minute presentations with time for questions. But very happily, we're the last session of the day, and we have an informal discussion planned with the CNPS Healthy Nursery Committee and the Phytophthora Native Habitat Working Group afterwards. So we'd love to hear your questions, your feedbacks, your troubleshoot problems, brainstorm together from 4:45 to 5:15, and we'll have plenty of time to get to the break. So again, I want to thank you all for your interest, and I really want to thank all of our wonderful speakers who are here today to share their experiences and knowledge and help us all to be more careful in our caring. So our first speaker today is someone who's been a mentor of mine and an idol since I got in the industry. Betty Young has been a nursery manager for 35 years, 17 of those years directing the Golden Gate National Parks Conservancy nurseries, which are, the bar in a restoration nursery and the idol template of our nursery. And then when she retired, she decided that the Sonoma County chapter of the CNPS needed to build a nursery up to the phytosanitary best management practices. So she's been working there with other volunteers to raise money, build, and now operate that nursery. So she's going to share with us one of the projects that she has been working on with a rare manzanita and looking at impacts of this topic in relation to that rare species. So please help me welcome Betty Young.
Thank you. This is probably preaching to the choir, but I think Susan and Diana wanted to start out with cautionary tale of the worst case scenario, and we're dealing with that in Sonoma County, where the one and only population of a manzanita species is dying from Phytophthora. And so to give you a little history, Sonoma County has 18 endemic species. CNPS stewards 4 preserves in the county to protect and enhance 10 of those species. The Vine Hill Preserve has 3 of those species. 2 of them, the Arctostaphylos densiflora, Vine Hill, Manzanita, Ceanothus foliosus vineatus, the Vine Hill Ceanothus, and Clarkia imbricata, Vine Hill Clarkia, all list California 1B1, protected species, rare species in California. And the Manzanita and the Ceanothus, this 1.6 acre preserve is the only place they currently grow in the wild in the world. Knowing that this piece of property became available in 1976, where's the cursor? There it is. Go over there. That line below the trees at the very top of the hill. There. Those are the naturally occurring Arctostaphylos densiflora. In 1976, before CNPS actually purchased the property, the only property they own in the state, at least I think still, was a vineyard. As the name implies, Vine Hill Preserve, Vine Hill Manzanita, Vine Hill Ceanothus, lots of vines around there, and most of that's what wiped out the other populations of Manzanita and the Ceanothus. So they, CNPS purchased the property to protect the Manzanita, and then in 1980, the central office, CNPS botanist, came out and to look at the Manzanita and not looking great, so they called a Manzanita expert who is premier propagator of Manzanita to take a look and ask him to propagate them. And so he began propagation, and so in 2020, this is that same area. So no Manzanitas were planted amongst the original population. He did tip cuttings and planted Manzanita all the way down the hill. So this road you see here that went through the vineyard is this area there. And so there weren't any planted plants put in amongst the remnant naturally occurring ones. And so in the next 20 years, he was able to put in over 80 clonal plants. And recently, a couple of years ago, the site steward actually labeled each and every plant on the site, and I'll talk about that later. So every plant has a name, an A for the remnant naturally occurring plants, and then B's for all the planted plants with a number. This is kind of current conditions. When the steward called me, our volunteer steward, called me in November of 2019 and said, "Would you come out and look at these guys? They're not looking too good." And so I went out and said, "Yeah, that's not good." So went back and got my gear to do pair testing, and went back out to the site and took 4 samples of soil. We couldn't take plant material. It was a rare plant. And so those are the pairs from the 4 soil samples I took from the site. Not too good. And so I took those pairs up to the CDFA lab and came up with Phytophthora pseudosyringae and Cambivora. And so CDFA had some convenient funding, so they immediately sent a plant pathologist and botanist out to the site and took samples. Don't you hate slides that you can't possibly read? These are their results. They took samples from other plants. Again, we couldn't take pieces of the rare plant. And they got various other diseases, and ironically, and one Phytophthora reading right up at the top where the road ran, next to the remnant naturally occurring ones. So I went back to our chapter board of directors and said, I need money to hire Ted, the guru, to come out and really figure this out and give us some advice on what to do. So he came out in June of 2020, and can you see that at all? No. He took about 17 additional samples, again, soil, since we didn't yet have permits. And this is kind of a slanted picture of the site from what I showed before. The other picture was taken from here looking up towards the road. This is the road. These are the naturally occurring manzanita. These are the planted ones. And we're on about a 20% slope. So what Ted found was cinnamomea in the naturally occurring manzanitas, and then on down the slope, Cambivora and cinnamomea. So thinking about, as we talk about, and sometimes it seems like everybody blames the nurseries, it could very well be that the Phytophthora that moved around among the planted plants could have come from a nursery, from nursery planted plants. Certainly up until about 10 or 12 years ago, we didn't realize how virulent the Phytophtheras were. And of course, these are rare plants that every rare plant botanist wants to see. So they're tracing through the site. They didn't know about disinfecting your shoes and tools and all of that. Our volunteer stewards that had been working at the site for 30 years, didn't know. They did an amazing job of weed control, but were they tracking in Phytophthora, especially if, maybe when we bought the property, the manzanitas were already infected? Was the vineyard closed down because the vines were infected? Who knows? So for whatever reason, Ted showed that the site was thoroughly infested and advised us to look for a place to establish new populations. So that meant getting a permit to begin collecting material to propagate, and then looking for new locations and working out agreements to plant in new protected areas. Lots of people come to me and say, I'll put one in my yard. That's not going to establish self-generating populations. So as Diana, I don't need this slide. Diana already said that after I retired, that nothing better to do, I decided we should build a nursery because I wasn't happy with the quality of plants that we had at our chapter plant sale. So we did that, and we are AIR certified. Yes, it is an accomplishment. You'll hear more about that from Mia and Martine. So I started, well, from the time Ted came out and said, find another place and begin propagation, then I wrote permit application from Cal Fish and Wildlife to collect from the manzanitas. And meanwhile, UC Berkeley collected from Bot Garden, Susan Malich, from the Ceanothus plants, and amazingly was able to grow those. So anyway, I got my permit in early 21 and collected from 11 plants on the site, both clonal plants and the remnant natural plants. Oh, that's where I put that. And for the propagators in the group, of course, we had to do cuttings. I assume everybody understands that the Phytophthora root rots, it's in the soil, enters in the root, grows up through the xylem. So if you're lucky, you can get clean material from the tips of the stems. So that's what we use to propagate. Got 33 plants that year. Each, of course you can't see it, each plant is labeled with the identification number of the mother plant it came from. Oh yes, for the propagators, I said, we used 1 to 6 perlite sun grow propagation mix and 1 to 5 dip and grow. Propagators know what I'm talking about. And luckily, thank goodness, in the meantime, Cal State East Bay Green Biome Institute approached our preserve steward and said, we would like to do genetic testing on the manzanitas at Vine Hill to see what we've got. And so they took material the year before, finally got results in January 22 as I was about to do my second round of cuttings. So these are her results. Again, I know, too small a slide to read. So Joanna Garavente from the Green Biome Institute came out, took samples from each and every manzanita on the site. Amazing. And did PCR tests on those and came up with 20 different genetic groups. We were nervous that, back in the 80s, when propagation was done, that they might have picked the healthiest plant and just done 80 clones of that one plant so that we had only one genetic individual. But thank goodness, and it doesn't surprise me because the person is very knowledgeable that did this. There are, in the clones and the genetic, the naturally occurring plants, there are about 15 of those left. There are 20 genetic individuals on the site now from that genetic testing. And so I was able to go back then and get additional material. My original plantings shown I had only 3 genetic individuals from the plants I happened to take cuttings from. So I was able to go back and capture the other material from the other genetic individuals. And so this is where the plants are at the moment. Last week, so we have about 180 manzanitas from 18 of the 20 genetic groups at the site that are ready to go in the ground as soon as the rain starts, and a few other details are worked out. Aside from the fun part of propagating, as I said, Susan Malich from Cal Bot Garden was able, from these, there are 2 remaining Ceanothus at the site that look, that's one of them. The other's only slightly better. Miraculously, she was able to propagate 22 of the Ceanothus. So we want to plant those out along with the manzanita this winter. And so while all of that was going on, then I was looking for sites to plant into. And so checked the historic botanical record for other occurrences for the same soil type, and came up with 3 sites. This is in Sebastopol area. And those are one site owned by the Sonoma Land Trust, just about a mile from Vine Hill, and then another site that's one of our conservation easements that we steward for another federally endangered species, but has appropriate habitat and similar soil type. So we'll put manzanitas there. And we're still trying to work on an buy-in from our regional parks. They have a good, appropriate site. And then the other things you need to do if you're going to move around an endangered species, and thinking about Phytophthora. So all of those plants that I propagated have been tested for Phytophthora and are clean. Yes, thank God. And then we'll be testing the soil at the planting sites to be sure it's clean. We don't want to put the manzanita back into infected areas. I've been trying to find Phytophthora-free soil under manzanitas so I can inoculate the plants with their own ericaceous mycorrhizae. So far, and all our members, manzanitas in their yards, I have not found clean soil, so they may or may not get inoculated. We'll keep working on that. The CNPS Central Office has written a management plan. Oops, go back. And we are working out the last step before planting, hopefully in December, is an MOU with the Sonoma Land Trust, so we know what's going on, and then recruiting volunteers to help us with that planting. And just to assure everybody, we got wads of permits to do everything that was done. And we have enough plants that all you bot garden people out there will need to put some into bot gardens. And the planting, I'm hoping, will be in December. The Sonoma Land Trust site requires, there's no way to truck anything in to the top of Pitkin Marsh. And so we'll be hiking from the road up about a 30-degree slope, hand-carrying manzanitas and water probably to the top of the hill to plant the manzanitas and then taking material up for deer protection. I'm really selling the volunteer opportunity here, I know. But if anybody would like to help us save these 2 endangered species, let me know. And I'll put you on my list. In fact, I have a sign-up list with me, so see me if you would like to help us out. Thank you.
All right, thank you so much, Betty. we very fortunately have this time to discuss later. So hold your questions, and we'll talk about them together later. And go ahead and welcome our next speaker. Our next speaker is Mia Ingolia, who's a senior biologist at the San Francisco Public Utility Commission, with more than 15 years of experience as a plant ecologist and a history of working with special status plant species, natural resource management, and GIS. Mia holds a Master's of Science from UC Davis and previously worked as a curator of the UC Davis Arboretum, and is also just a huge plant fan who sorts of tells me things like, I'm on a Calicortus quest now. So please welcome Mia.
All right. Good afternoon, everybody. I'll try to keep you awake. So I'm going to give you a little bit of an overview first of the San Francisco Public Utilities Commission. So we provide power to San Francisco Public Services, wastewater treatment and disposal to the residents of the city, and water through the Hetch Hetchy Regional Water System to 2.6 million customers in 4 Bay Area counties. The system was designed over 100 years ago to use gravity to deliver water and generate electricity, and there's portions of the system that have been in continuous use for the last 80 years. So the Natural Resources and Lands Management Division that I work in is responsible for the stewardship of 60,000 acres in 3 Bay Area counties. Our watersheds provide about 15% of our water supply and most all of our local storage. Oh, did I just go wrong? Here we go. Okay. And in addition to our primary mission, which is to provide high quality, affordable, and reliable water, we also have a stewardship policy that commits us to responsible natural resource management methods that protect and restore native species and the habitats that support them. Our watersheds contain about 20% of California's native flora and over 300 species of birds, reptiles, mammals, and amphibians. We have about 35 plant and animal species that possess endangered or special status classifications. Another 50 of our plant species are considered locally rare for our area. In 2002, we launched a voter-approved $4.8 billion program a water system improvement program in order to improve reliability. Of these 80 projects, 16 of them occurred in the watersheds and disrupted habitats that had not been disturbed in over 80 years. Because of these impacts, we had to do a lot of mitigation. So we started a habitat restoration program that's called the Bioregional Habitat Restoration Program. It attempts to restore 2,000 acres of the 60,000 acres of the city-owned watersheds. So we have multiple restoration sites in both watersheds. This is the biggest single site. This is in the East Bay, just up the road a little bit from here. It's a 2.5-mile-long riparian restoration corridor where we planted over 200,000 plugs and over 200,000 trees and shrubs. So prior to the initiation of that habitat restoration program, we had experience on the Peninsula watershed with losing a lot of our tan oaks and 30% of our coast live oaks to sudden oak death. At that point, we started funding research through an MOU that we have with the Forest Service to investigate the causal agent of sudden oak death, Phytophthora morum. And through that process, we found out that we had other Phytophtheras that had been introduced into the watershed, and they were having impacts on plants like Pacific madrone and coffeeberry. Oh, I keep doing that. Nope. Okay, so what is Phytophthora? Phytophthora means plant destroyer, and Phytophtheras are water molds that thrive in wet conditions. There's over 110 species of Phytophthora, and several of them cause impacts in similar Mediterranean climates. The dead madrone picture I showed you, that is being caused by Phytophthora cinnamomi, and Phytophthora cinnamomi is a bad actor and also in South Africa and all over in Australia, where it's mostly killing proteaceous species. So with this information in mind, when we were making the contracts for our habitat restoration sites, we thought we built ironclad specs, and we took really significant measures. We said that all the materials had to be pest and pathogen free. We did lots of inspections, lots of decon and disinfections, but the specifications were kind of new to the industry. They were met with a little bit of resistance, and they weren't strictly followed in all cases. And in the fall of 2014, we did a really large planting effort. We noticed plants dying in the field, sent the plant pathologists out, and figured out that we had introduced multiple new Phytophtheras into multiple restoration sites. So at that point, we stopped planting container plants altogether. We also banned the use of all the import of all organic materials unless they were thoroughly heat treated for Phytophthora, and we created an institutional standard operating procedure for decontamination that applies to all PPE, tools, vehicles, and equipment. Right around this time, the Phytophthora in Native Habitats Working Group was also formed, and we enthusiastically joined, along with several Bay Area land managers, plant pathologists, and California native plant nurseries. And these were all people that were concerned about this issue and interested in trying to figure out how to eliminate these Phytophthora introductions into wildlands. So we created a bunch of guidelines for nursery management and restoration activities that work to exclude Phytophthora and minimize the chances of you introducing them into your wildlands. And that brings us to our next capital improvement project, which we call the Sunol Long-Term Improvement Project. This is kind of two different construction contracts. The first involves demolishing an existing yard and rebuilding it. And the second is enhancing the educational value of our Sunol Water Temple by constructing the Alameda Creek Watershed Center. So the Watershed Center will teach visitors about the natural resources of the Alameda Creek watershed, its history, and its role in the SFPUC water system. As part of this, we have a 3-acre native plant garden that features the plants and the plant communities of the local watershed. So this garden has about 25,000 plants in it. And then the yard project called for 20,000 plants, also all California native, and they were mostly in bioswales, and it's designed to capture the surface water runoff of the yard. And then between the two projects, there's about 100 species. So because these sites are wildland adjacent and we know they're going to have an ongoing need for plants, we had to figure out how in the world we were going to import large amounts of soil, large amounts of mulch, and over 50,000 plants, and do that in a low-risk way. So the first thing that I had to tackle was soil, and I did manage to find a planting mix that actually you can get on a large scale, that has 2 different types of compost in it, and we went out and tested it multiple times, and it actually does heat to lethal temperatures to kill Phytophthora. And so then we worked with the company who has the compost, the planter mix, in order to make sure that once it actually had reached those lethal temperatures, that they handled it in a way that it was clean, and that when it was picked up, it was also picked up and processed in a way that made it clean. For the mulch, what we did is at the yard, since it's mostly bioswales, I went ahead and used desert gold rock mulch on everything, so that's pretty low risk. That was easy. But for the Watershed Center, I needed 1,400 cubic yards of bark mulch, and I wanted to use the bark mulch because it's just not a garden that's really well suited to rock mulch. So in order to do that, we worked with Phytosphere Research and Ted Zwicky. We have a lot of land, we have a lot of trees that die, so we happen to have gigantic log piles here and there. And we decided that the devil we do know is better than the devil we didn't, and we wanted to use our own logs instead of buying outside mulch. And we undertook a pretty big project where we pulled gigantic conifer logs, mostly Doug firs. We hand debarked them. They were all on separate metal plates. They were high pressure steam washed, and then they were directly mulched with a bark trunk chipper straight into clean, disinfected trucks and then taken directly to the site. So We decided we wanted to use container plants for the garden and decided that we were going to build a native plant nursery in order to supply those container plants using the objectives as laid out by the Phytophthora working group. I want to go over today what makes the nursery a little bit more like a lab than a farm. And I also want to say that we had the luxury of creating something fresh and new. And a lot of people don't have that. They're going back and they're trying to retrofit something. So don't be discouraged, because the other thing I'll say is that the way that we've done this is not necessarily the way that you have to do it to be in compliance with the BMPs. And so this is the way that we chose to do it, but it's not the only way to do it. So before I go into the nursery, I just want to point out that the best management practices do start outside the nursery. So when we are out in the field and we are seed collecting, we only collect from healthy plants. We do not collect seeds off the ground. All of our tools, containers, hands, everything are sanitized regularly. If we absolutely have to collect from the ground, which we do sometimes, those seeds are always kept separate, and then they're bleached in a mild bleach solution before they are propagated. So here is an overview aerial of the nursery. So it's a 1-acre facility that was completed in 2018. The entire site was graded to make it so that it would not have any sort of pooling water, and because of that, there's places where there's at least like 6 feet of aggregated base. On top of that, we have another 2 to 3 inches of drain rock. So the facility has 3 growing areas that are situated in a way that's conducive to like efficient flow of the plant material. In the back, we have a small greenhouse. We have a 8,000 square foot shade house, and then a 13,000 foot full sun area in the front. We have a small office that we also use for seed cleaning. We have a garage that's used not only to store equipment, but is also used as our main propagation area. The entire facility is fenced, and it has a privacy cloth on it that is intended to minimize splash, dust, and weeds. We have cargo containers where we store all of our clean pots. We have a 20,000-gallon tank farm, water tank farm, that is intended to supply the nursery with water for 2 weeks if our water lines get taken out of service. And we also have 2 bulk soil bins that are situated at the front of the nursery so that those soil delivery trucks do not have to enter the clean footprint of our nursery. So the motto of our nursery is start clean, stay clean. And everybody who works at the nursery is expected to follow the phytosanitary guidelines as laid out all over in the nursery with a ridiculous amount of signage. All of our benches are made of metal. All of our propagation areas have metal benches, and all the countertops, we do seed cleaning, it's all metal. No work surfaces are made of wood because it can harbor pathogens. All the surfaces underneath the benches are maintained to prevent puddles, eliminate splash potential, and remain free of any kind of vegetation. We also are pretty diligent about making sure the gravel gets replaced. We don't want any kind of muddy puddles or anything, and we have landscape fabric underneath all the growing benches all over the whole nursery, underneath all the growing benches. Okay, so anybody who works in, anybody who is out in the field, or a contractor, visitors, if they show up to the nursery in dirty clothes, they are not allowed into the nursery, and we funnel all of the traffic through one entrance with a cleaning station and signage. Anybody who enters the nursery has to disinfect their shoes with either quaternary ammonia, bleach, or isopropyl alcohol before entering the nursery, and then we have foot baths in multiple locations all over the nursery. There are decontamination supplies everywhere you look, and we do a lot of vacuuming and sweeping to make sure there's not soil in any of our growing areas that is not where we want it to be. It should be in the pots, not anywhere else. So as far as pots go, we only use new or clean and sanitized pots. Anything that leaves the nursery, when it comes back, it either gets washed down and then sprayed again with bleach, quaternary ammonia, or isopropyl alcohol. In some instances, what we do is we take those pots and we actually wash them down, and then we steam them. We have a highway-ready mobile boiler that we attach to these soil steam wagons. We have 2 of them. They each can hold about 3.5 cubic yards of soil, and so we also can put pots in there to steam the pots. So the goal here is we want to hit 140 degrees Fahrenheit for 30 minutes in order to feel good that we have managed to kill any Phytophthora that is in that soil. Water and irrigation. So we have both a potable water line and a raw water line that are filtered through a 5-micron filter, and then it's treated with a UV system before it waters any of our plants. We did have UC Davis come out monthly for a year to test the raw water because it is downstream of one of those infected habitat restoration sites, and we've yet to get a positive from any of that raw water testing. That does not mean it's impossible. All of our benches are cleaned and sanitized before placing new pots on them. We also space the plants. We group them by species and then space them away from each other in order to reduce the risk of contamination via water splash. All plants on benches are at least 3 feet above the underlying surface in order to minimize splash from the ground, and container plants and hose nozzles are never, ever placed on the ground. It does happen on occasion that a plant might blow over in the wind. The vast majority of the time, that plant will just get thrown out. There was one instance where we really needed the tree. And so then it's quarantined and we test. No amendments are used unless they have reliable documentation that they're free of Phytophthora or other plant pathogens. And we don't use any fungicides at all because they just have a suppressive effect and they actually don't kill the pathogens. So we put a lot of time and effort and money into creating this nursery based on these new BMPs, and there was no other facility out there that had attempted to do this. We actually didn't really know if it was going to work or not. And since 2019, we have now tested 86 species, over 300 Phytophthora tests, and we have 0 positives, and we've managed to plant over 50,000 plants. Oh, that's this slide. So I didn't talk about my disease slide, I skipped it. I will say we also sweep through the nursery on a regular basis to do disease patrol, and then we do a ridiculous amount of testing. So that's that over 300 tests that I mentioned. We do this bench leachate testing where they water each plant for a specific amount of time. They capture the water. Then they put a hopefully green D'Anjou pear in the water. They put it in a controlled temperature cabinet and look for lesions. If it develops suspicious lesions, then we send it to Davis for testing. So the nursery has been a big success, and we're very proud of it, but that doesn't mean that we won't get Phytophthora in the future, and we have to stay vigilant. And there also are always ongoing challenges for us. We continuously have birds that keep trying to nest on all of our tables, and that is not part of the BMPs. Also, we've only propagated 1 plant from cuttings. We're just sort of nervous. We did a manzanita from cuttings just because it's so slow by seed, and seed propagation just can be very slow and still hard even in a nursery setting. Also, outside the nursery, erosion control materials, they're organic materials that I have yet to ever find any sort of heat-treated erosion control materials. We do a little bit of treatment at the nursery and for really sensitive habitats, but I would love to be able to purchase heat-treated erosion control materials. And then we have ongoing issues still with contractor compliance. Those dirty shovels are one of the Sunol yard project. They showed up to do the work, and I went to inspect everything, and there was these really dirty trucks, dirty shovels, and I said, "Did you guys read the specs?" And he said, "Oh, they're in the truck." And I was like, well, you guys aren't working today, so you can pack it all up. And they came back the next day and everything was sparkling clean and they had bought all brand new tools. So that was that was good. But we're just always going to have to, pay attention and do a lot of contractor oversight. And so with that, I can take any questions if I have time. Go ahead.
I'm actually really familiar with you guys because I worked years ago. I did some design consultation for the initial phases of the visitor center out there. And I'm really proud. Thank you. I'm really proud of the work you're doing there. That's incredible.
Are you Greg Rubin by chance?
Yeah, I'm Greg Rubin.
Yeah, I've never met you.
So it looks wonderful. Are you guys experimenting at all with trichoderma?
No, but so that is something that I think about a lot. I'm a little gun shy to start introducing organic material just because we've been burned, but I read all kinds of, articles about how compost, trichoderma, inoculations can all be really great for infected sites, but I'm a little scared, I'll be honest.
And I guess, maybe I'll save this for the discussion afterwards.
Okay.
I want to ask about Argentine ants, so I'll wait till
We do a bunch of stuff for Argentine ants. My boss...
You do?
Yes, so my boss did her whole PhD on Argentine ants, so yes.
Oh, I got to get her number.
Okay.
Yeah.
All right, so my time is up.
Okay, that was great. Thank you, Mia. And as we said, we have time for more questions when we get together at the end. So it's really nice. Betty gave us sort of the potential impacts of these organisms, and Mia is giving us sort of like, but we have a solution. And then Martine is going to kind of give us the ongoing saga story. And Martine Glaros works with the Parks Conservancy Nursery since 2019. Her relationship with Phytophthora management arose during an internship with Presidio Trust, where she studied the prevalence and transmission of Phytophthora within the Presidio. And currently, she's heavily involved in the Parks Nurseries Phytophthora testing program. And Martine graduated from Humboldt State University. Woo woo. So please help me welcome Martine.
I forgot that I wrote that. I was like, how did you know? Okay. So my name is Martine Glaros, and I'm one of the staff at the Golden Gate National Parks Conservancy's Nurseries. And there we go. Today, I'm going to be talking about the most turbulent aspect of our phytosanitary practices, which is testing for Phytophthora. So I'm going to take us on our 9 years and counting roller coaster of how we've approached testing. First, some background info. In this presentation, we have data from 2 nurseries, the Presidio Nursery in Presidio National Park in San Francisco, and my second home, AKA the Marin Headlands Nursery, right across the Golden Gate Bridge. And our purpose is to grow native plants for ecological restoration projects around the parks. We also have interns, we do a lot of community programming, lots of cool stuff. And before I talk about our approach to testing, I'm just going to very rapidly, strobe light style, go over our general BMPs. So our shade houses are graded and paved. Our plants are on raised plastic benches. All of our soil is steamed at least 140 degrees for at least 30 minutes. All of our pots are washed and then either steamed or bleached. All of our growing structures are deep cleaned annually. Any propagation supplies or surfaces or anything that enters a greenhouse or shade house is sanitized beforehand. The vast majority of our plants are grown from seed. And we conduct Phytophthora dusting each year. And this is mainly through pair baiting, and the CDFA helps us to analyze our results and do the culturing. And for us, following our BMPs means addressing as many Phytophthora vectors as feels feasible. So we pour all this energy into growing clean plants. How do we know if they're clean? Well, we test them. Testing is the barometer which we assess all the rest of our BMPs. And how do we know if we're doing a good job testing? That is a really good question. And I'm not here to be like, all right, folks, we have it all figured out, so here's my TED Talk on the perfect approach. It's more like being transparent about our process in order to continue in a conversation about how much we should be testing as a restoration nursery. So, as we all know, it takes a lot of effort to do Phytophthora testing, so how much is enough when you have limited resource and limited staff capacity? So again, no perfect answers, but I'll start with our data. So this is a pretty comprehensive visual of our testing data over the last 9 years. The number here is the year. The one below it is how many plants we grew for that year. The blue bars are the percentage of plants that we tested, and the number above it is how many tests we performed. So, for example, in 2017, we grew 87,000 plants. We ended up testing about 30% of those plants, and we performed 192 tests. Here's our same data with our Phytophthora positives. So we got 18 that first year of testing, 1 the next year, and another one in 2020, which I will talk about. But as you can see, we have 3 very distinct eras going on here. So I'm going to dive into each of those eras and talk about our approach to testing and why we did it that way. Okay, so first testing era was 2014 to 2016. And 2014, news of Phytophthora had just crash landed on the nurseries. And during these 3 years, almost all the testing we did was destructive sampling. And destructive sampling is great because it's super efficient. You just find your symptomatic plant, make some pear bait soup, and you're done. And of course, the drawback is that you're destroying everything you test, so it's hard to test a large portion of your plants at the nursery. So during these 3 years, we tested 2% or less of any of the plants that were here. So here's 2014 when we got those 18 positives. We implemented our BMPs in 2015. And then the next year, we got 1 positive, and the year after, we got 0. So of course, testing is an indicator. It's not a guarantee of clean plants. But as you can see, there's a really clear pattern here of, okay, we implemented our BMPs and we stopped getting positives. So this was the trend that first kind of gave us faith that the BMPs were working. The next testing era was 2017 to 2019. And I've been calling this like our golden era of testing, because we had a phytosanitary technician that was testing in full swing. And we also switched to effluent testing, so we were able to test a lot more plants. And we developed a really thorough criteria for what to test, like how to make those decisions. I'm just gonna. So under this, anything that fell in this criteria was tested between 50 and 100%. And that includes cuttings, bulbs, and divisions, so anything that was vegetative and not grown from seed. Anything symptomatic, so anything that was chlorotic, necrotic, stunted, brown, funny roots. Holdovers, so anything that had been in the nursery for longer than a year. High-risk species, this was a list that we developed of about 12 native plant species that frequently test positive in native plant nurseries. It includes like toyons, oaks, etc. And medium-risk species, which are plants that are known Phytophthora hosts in nurseries, but don't necessarily test positive quite as frequently. We also had pretty large batch sizes during these 3 years. The average batch size was about 150 plants, which is 3.5 times larger than what Phytosphere recommends at 42 plants per batch. And I think in some ways this increased our testing integrity because we were able to test such a huge portion of our plants. And in other ways, it decreased our testing integrity because once you start having really large batches, it can dilute your sample. But anyways, what all this resulted in was a lot of testing. So you can see that our phytosanitary technician ended up conducting hundreds of tests on tens of thousands of plants and was testing 30 to 40% of the plants in the nursery. All by herself, which still like blows our minds. And we got no positive detections during those years. And we thought it was really important to test a huge portion of our plants for some era because our BMPs were still kind of testing their little wings. And so it was important to know with a really large sample size, to be able to assess if they were working or not. This was an incredible amount of labor, so we had no intention of being able to continue at this level indefinitely. So there was always this kind of budding question of, okay, every year we get more and more faith that our BMPs are working well. What's going to be our approach to reducing testing to actually match our staff capacity? And the answer to that was 2020. So 2020 was like a little apocalyptic. Y'all were there, so you remember. We had really severe forest fires in California that were like making it poisonous to go outside for weeks on end. Of course, that's the year the pandemic came crashing down. So because of that, we couldn't have volunteers, we couldn't have interns. We had some really heartbreaking staff layoffs. And at the same time, we had to grow more plants than ever before in the nursery's history because of the Tunnel Tops project happening at the Presidio. So we were stretched very thin. And actually, a really key insight we got out of 2020 was that even though we were stretched so thin, it didn't impact our BMPs all that much. We had already purchased our boiler, we had already graded our landscape, we had our benches and our cultural shifts on lock. So because of all that initial investment in 2015, even though we were kind of operating in this crisis skeleton mode, we were still able to carry out our BMPs really well. There's a slide missing, but except for testing, we ended up testing less than 3% of our plants for that year. And it really forced us to that precipice of like, okay, we haven't gotten a positive in 4 years for real. We can't keep testing 30% of our plants. Of course, because it was 2020, we did get one positive. And that positive was on Fragaria vesca. It was pyromorum on some strawberry cuttings. And at first, we were just like devastated and freaking out. And then we actually became grateful because the strawberries were collected from a site that we later found out was known to be infected with sudden oak death. If it had been grown from seed, we would have had no idea what the vector was. Like, was it because I dropped the chopstick and didn't spray it? Because I washed a pot badly or something? And it was because I literally collected sudden oak death from the field and planted it in the nursery. So because the vector was so clear, it didn't force us to question the rest of our BMPs. And it actually gave us some confidence that we were able to biasly select plants well and catch a positive if it was in the nursery. So there's the stats on 2020. So 2021 to 2022, we really grounded back into that question of okay, how do we balance testing enough with our staff capacity? And to find that balance, we made 2 major changes. So the first one was that testing went from being one person's job to being everybody's job. And in 2021, we had about 3 people testing once a week when the weather allowed for it. And in 2022, we had our entire staff drop everything for 6 days of intensive all-day testing. And we found that a lot of the labor is in setting up, breaking down, and getting prepared. So by consolidating all of that into a concentrated time and having everybody on board, we really got to fly through some testing. And the other change we made is that we changed our criteria for what we tested. And to do that, and again, this is not us presenting the gold standard of like how this should be done. This is just what we've been doing for the last 2 years, and we're very curious about how other nurseries have approached this. But the first thing we did was develop a list of risk factors. So the ones on the left are more heavily weighted. Those are like our biggest red flags. And the ones on the right are things that could also increase the risk of infection, but aren't as heavily weighted. So I will come back to this slide in just a second. But just to give you this, so our criteria is if there's 0 to 1 risk factors, we choose not to test. If there's 1 to 2 risk factors, we'll test between 2.5% and 10%. And if there's 2 or more risk factors, we'll really bump it up to testing like 25 to 100%. So to walk you through an example, let's say we had some really awesome, luscious-looking Juncus effusus in the nursery, and it was grown from seed, it had normal treatment, it all looks fine. We would choose not to test that. Even though it's a medium risk species, so it technically has 1 risk factor, we really want to put our efforts into things that are the riskiest, which means saying no to some batches, so we would say no to that. But let's say we have the same Juncus effusus, and it's been at the nursery for a year, so it's now a holdover. That bumps it up to having 2 risk factors, so we'll go ahead for that 2.5% to 10%. And then let's say we move it close to the edge of our hillside where the headlands hills come. Now it's close to the edge, which brings it to 3 risk factors. And maybe we overwatered it for a month, so it was kept really wet. At this point, we're testing 25 to 100% for sure. So you can really see how the risk factors accumulate. And these days, when we decide what to test, it looks like walking through our entire shade house and measuring all the batches up against this criteria here. And we'll come up with a list of how much we would be testing under this criteria. And from there, we'll either be like, great, that'll take us 8 days with all of our staff, sounds awesome. Or we'll be like, oof, that's gonna take us like 3.5 weeks, even with all of our staff, and we don't have time for that with running program, collecting seed, et cetera. And in which case, we'll kind of renegotiate things. So just for the stats, we ended up testing 6.8% of our plants in 2021 and 9.2% in 2022, which is pretty good for 6 days. And we got no positive last year, still waiting for results for this year. So just to sum things up, yeah, Liz, with 2023 and beyond, these are some of the things that we're hoping to incorporate into our testing. So one thing is conformity to protocols. We already are following Phytosphere's protocols quite strictly and are in sync with them, but we're really trying to weed out any subtle differences that might be present. For example, we were baiting our pears in the vessel on the left, which is 2 inches longer in diameter than the one Phytosphere recommends on the right. And is there going to be a situation where the zoospore can't swim those 2 extra inches and we don't get the positive? Maybe, we don't know. The point is we're really trying to conform to exactly what other nurseries are doing. So that way, whether we're getting positives or negatives, we're comparing ourselves to something really standardized. Another thing is expanding our bait variety. Pears are a pretty good happy medium, but different Phytophthoras do prefer different snacks. So this is a pretty time-effective way to improve the integrity of the testing. This is a tip that I got from Diana at Watershed Nursery, so thank you. And this is destructive sampling all year leading up to testing. So we do all of our testing at the end of the year when the plants are at their most fully grown. And she suggested that we also do destructive sampling all year long, especially on our most symptomatic plants. So that way, it can really help us keep our finger on the pulse of what's happening in a very quick and efficient way. Emphasizing checking roots rather than top growth for symptoms. You know, it can take a while for that chlorosis and necrosis to really show up on top. So while we're doing water monitoring, et cetera, I'm focusing our observation on the roots. And the last thing is continuing conversations with other nurseries. We're very curious what y'all are doing, like how you're approaching how much to test, and we're excited to have conversations with you all and like coming together in integrity. So thank you to many people.
Okay, that was awesome. Thank you, Martine. So we've had some of the impact on a rare species, the potential impacts out, that impacts out in the wild, and then the solution. And then Martine's taken us into like the depth of the testing world and in the light of other sort of apocalyptic times. And there is a couple pairs down on the CNPS Healthy Nurseries table. So if you want to see what a Phytophthora infection, that's Phytophthora nicotiana down there. So go check it out. And now we get to go back out into the field. And we get to go out into the field in Southern California, too, which sometimes people are like, doesn't happen down there. I'm like, but wait. So our next guest is Sebastian Fajardo, who earned his master's degree in Chile researching Phytophthora species associated with declining native forest stands. Currently, Sebastian is a PhD candidate at UC Davis, studying under Dave Rizzo, investigating the diversity, distribution, and pathogenicity of, I didn't say that right today, of Phytophthora species associated with natural and restoration areas of Southern California. Please join me in welcoming Sebastian.
How do I do this? Just, there you go, perfect. All right, cool. So I have this like more of a fancy title right now because I forgot to change it and modify it a little bit because a couple months ago I presented in the IUFRO conference. That's just Phytophthora people for like 5 days in a row, and that was pretty intense. So basically my titles more refer to the Phytophthora that we sampled down, or we found down in the Angeles National Forest. And one of the things and the tendencies that we've been finding is that not all Phytophthora are equal, in the sense that we're finding different Phytophthora species, we're finding them in different areas. And I'm going to talk a little bit about like why we think we're finding these different Phytophthora. And we also found like these Phytophthora have different levels of aggressiveness. So I want to go into the depth a little bit about that. So first, I know you guys have been hearing at least like 3 or 4 talks about related with Phytophthora, but nobody's really talked about Phytophthora itself as a pathogen. So one of the cool things about this organism, it has these sporangia that release these zoospores, about 8 to 20 of them per sporangia, and they all have these little 2 flagellas, which is very unique. That's why they're not considered fungi. They're from a whole different kingdom. And they all swim through chemotaxy, and they try to find different roots or different vegetation material that they love to eat. But one of the curious things, or very unique things also about Phytophthora, is that they have these, can I move this? Yeah. They have these resistance structure that's product of their sexual reproduction. And the unique thing about this is that they have this really thick wall, which allows for resistance. So it's been seen that these structures actually allow for this Phytophthora to last up to 13 years in soil samples. So they're very hard to remove and exterminate. And the other, which is also considered a long-term resistant structure, but not as intense as oospores, is chlamydospores. Now, all these species, like I mentioned, they're not equal in the sense that certain species possess these traits and some of them don't have these resistant structures. And that's one of the things that we've been seeing out in the field. So as Mia mentioned, Phytophthora is a plant destroyer, and it's very commonly known in the agricultural area where we can have causing blights, affecting root rots, affecting color rots, and affecting different agricultural commodities. But they're also present in natural areas and forest systems. And these Phytophthora in these scenarios cause more of a landscape, they cause like more problems at landscape level, that's what I'm trying to say. So a lot of these times, it's complicated to control these because first, it's not efficient and there's a lot of restrictions applying chemicals in these forest areas. So a lot of the measures are, which Dave might talk a little bit about in the next presentation, they're more focused on preventive measures, start clean and stay clean, and also eradication efforts, trying to remove the pathogens from this area. But it results very complicated. A lot of these species, just like in the agricultural level, they cause similar symptoms with root rots, stem cankers, foliar necrosis, depending on the species. So there's several examples of Phytophthora around the world. In the southern hemisphere, I like to always mention Chile with the exotic plantations of Monterey pine. There's a Phytophthora that started devastating, it was about now maybe like 20 years ago. Some Monterey plantations. Also, they're in native forests too in Argentina, affecting these Altrocedrus, causing stem cankers. Now we're all familiar with Phytophthora morum, with sudden oak death. And then down in Australia with the dieback of Jara, where they actually named Phytophthora cinnamomi as like a biological bulldozer. Now, the first disease of Phytophthora was described in 1910, but then it has gradually increased. As we can see also, some of the tendencies that happen is that once a Phytophthora disease is described, there's like a spike in description of species. This does not necessarily mean that we're causing or introducing more species, but there's also more tools and detection methods to describe these species. And also it creates and increases the awareness that Phytophthora can be introduced into natural areas. So that's why we can kind of see a peak, especially after sudden oak death. Now, why is this happening? Why are Phytophthora being introduced into natural ecosystems? We already seen the last 3 or 4 slides. They're associating restoration areas as a potential way of these Phytophthora being introduced. Finding similar species in restoration areas and nurseries, even same genotypes. So I don't want to go into depth about all of those different cases. But what I want to do now is kind of give context to the project that we initiated down in the Angeles National Forest. So I'm going to take you guys and travel 290 miles down south and bring you to the Angeles National Forest, which is an area that's protected by U.S. Forest Service, manages as well. And it's considered a very dry area, and it's even considered the most fire-prone area in the United States. So a lot of the vegetation types that we find in the Angeles National Forest include chaparral vegetation, oak woodlands, and some pure conifer stands. And the most important thing about the Angeles is that all this this area is considered a biodiversity hotspot, so it provides a lot of ecosystem services as well. Now, one of the most dominant species in these areas is chamise. A little spoiler alert, Phytophthora loves chamise. I'm going to show you a little bit, some pictures of our pathogenicity test, which is a little bit concerning, considering the importance of chamise to California. Like I mentioned, it's a widespread member of the California vegetation. The Native Americans used it for medicinal properties. It said that the bark of chamise is used to treat syphilis. I don't know, I'd rather go to the doctor, but not I don't have syphilis, but and it's really important for forage. But one of the cool things about chamise is that it produces this really pronounced taproot that's really good for erosion control, and it's very suitable for revegetation. So that's why, considering that it's very susceptible to Phytophthora, this is actually very concerning. This is again showing the distribution of chamise in California, focused mostly on the coastal range, but as you can see, from the north to the south of California, chamise is present. It's a very important species. The other cool thing is that chamise also is resilient to forest fires. As we know, in California, everything burns. So this is actually a photo from Stebbins Cold Canyon, which is near Lake Berryessa, near Davis. And this is 1 year post-fire. As you can see, chamise just was burnt, but it resprouted. Another way that chamise kind of survives fires is also through seedling recruitment. However, as we know, increased forest fires, intensity, severity has really caused a big toll on the ecosystem. So this is why there's several projects were initiated in Southern California, mostly financed by the National Fish and Wildlife Foundation. And this is how this project I'm going to talk about today was kind of formed. It is a collaborative project between the Forest Service and UC Davis. And we were in charge to assess the Phytophthora distribution in these pre-restoration areas that wanted to be restored and that were severely degraded, and we wanted to assess if Phytophthora was present. So this project was focused on three main fires that occurred approximately 20 years ago. The copper fire, we have the Sayer fire, and the ranch fire. Now, due to financial reasons and time constrictions, we focused a lot more on the copper fire area, but we did sample the other two fire areas. So what did we do? We went down there 5 times between May 2018 and May of 2021, and we collected soil samples. We collected from underneath plants. We collected from bulk areas, which means areas that did not have any vegetation. This would mean stream beds. This would mean also barren lands, off-road vehicle trails. As I mentioned, we also collect underneath plants, and this is where we categorize these samples as rhizosphere samples. So anything that's underneath plants we consider as rhizosphere soil. And we try to sample from different vegetation types, in this case chaparral and oak woodlands. And I mentioned also that we collected from stream beds and upland areas. So we collected a bunch of samples, and then we recategorized them, and which helps to kind of understand why we're finding certain Phytophthora. From these soil samples, we then baited with pears and rhododendron leaves. I'm not going to go into depth of that because we already talked about that. And through molecular identification through the ITS region, we identified them to species level. These are some of the examples of the areas that we sampled down in the Angeles. Like I mentioned, these stream beds. There was a few perennial streams, but most of them were ephemeral, so most of them, they were just dry stream beds. We sampled upland areas. Anything that's upland, we consider it's outside the stream beds. Chaparral areas, and oak woodlands. Now, I try to force myself on not showing too many lists of Phytophthora, but I think it's a good way to kind of assess that we actually found 14 species of Phytophthora, 12 described species, a few undescribed species, but instead of like kind of breaking your head open with all these lists of species, focus that we also found them in a lot of common chaparral species. From chamise, from black sage, we found thick leaf yerba santa, from coast live oak, and other riparian species. And as you can see in this map of the copper fire area, that a lot of the Phytophthora were mostly associated with riparian areas. Well, as I mentioned, some of the Phytophthora associations with some of the vegetation that we found, some of these thick leaf yerba santas, some California buckwheats, but we also found certain Phytophthora under off-road vehicle trails, which I'm going to talk a little bit about in a few more slides. And also in stream beds, where we found a lot of, most of the diversity of Phytophthora were associated with stream beds, which makes sense. As was mentioned, Phytophthora is a water mold. They're more related with brown algae rather than fungi, so they really like water. However, it was very curious that we found them in drier areas. These are other species that we found Phytophthora. I don't want to bog down too much in talking about this. But this is what we found really interesting in some of the tendencies that we started finding, that we sampled in these different contexts. The different soil samples were then classified in either, like I mentioned, in upland areas, rhizosphere, bulk samples. And one thing that I don't want to that I want you to notice is that although we found a lower frequency in certain areas, we still found Phytophthora in these really dry areas, in these upland areas and underneath plants. However, the frequency of Phytophthora increased significantly every time we sampled in river areas. So if you can notice that here in chaparral areas, there was a less frequency of Phytophthora compared to oak woodland, but once we sampled riparian areas, in these both vegetation types, the frequency even doubled or even tripled. So Again, Phytophthora likes water, which makes sense. We also, something that's very concerning is on off-road vehicle trails, we found several Phytophthora species as well. And like 10% of our samples in those areas were positive for Phytophthora. Now, again, I lied and I'm showing another list of species, but I want you to focus on these species that are highlighted in red. And as you can see, these species were found in these drier areas, either chaparral or oak woodland species, oak woodland vegetation types. Now, these species, Crassamira, Multivora, and Cactorum, what they have in common is what we call them homothalic species. That means they can inbreed between themselves. So when they're able to do that, that means they can produce oospores. Remember in the first slide I showed you these resistant structures? So this allows these species that we're theorizing, that we allow these characteristics or these traits allow the survival of Phytophthora species in these dry areas, which is very concerning because we generally know as Phytophthora being more prevalent in more humid areas. If we're finding them in these dry areas, what does that mean? So this is another image of just to show how the diversity of Phytophthora and the different species that we're finding depending on where we're sampling. And directly in waterways, we found Phytophthora crassamira, Gonapodides, but in these upland areas, we found Phytophthora cactorum, which is another very common nursery Phytophthora. The other thing, as I mentioned, is these off-road vehicle trails. Now you can't really see here, but this is one of the sites we call Cowtown because a lot of cows come in and graze. But also they have this like off-road vehicle trails. And you can see here the Forest Service put a little barrier to avoid motorcycles or any type of off-road vehicles. But they clearly did not care, and they just passed through it. So one of the things, considering that we're finding Phytophthora in these waterways and these off-road vehicle trails, is that we can associate these as potential dispersal ways. So Phytophthora can move through water and can move through these soil movements, reaching different areas of the Angeles National Forest. And it's concerning that these Phytophthora are able to survive in these drier areas. Now here comes the more gruesome part because we found a bunch of species and we decided to test a few of these species with these chaparral plants. So what did we do? Thanks to the Rancho Santa Ana Botanical Gardens, they provided plants and they also provided a lot of information on how to grow these plants. I would say most of my PhD right now has been growing plants. So it's been really helpful. We focus on 4 main species that we consider that were important for restoration. Thank you. And they were commonly sampled down in the Angeles. We did 2 different types of infestation methods. We did a soil infestation where we literally grow Phytophthora in these these spawn bags, and then we put them in here next to the plants. And we also did zoospore infections, meaning that we produce zoospores to infect the little plants. One thing that we did, one of the methods to do, like I mentioned, is through the soil infestation. We put the Phytophthora in the soil next to the plant, and then we flood the plants. This flooding allows Phytophthora to sporulate and start infecting the root system. These are some of the images that we obtained, some of the symptoms, a lot of an immediate wilting, and I don't know, you can't really see in this picture, but some of these Phytophthora are really aggressive in the sense that they started moving up the stem of the plant, causing what we call cankers. In general, it's a lot of canopy symptoms that we see on these plants. Now, one of the things that did happen is that, as you can see, the controls don't look very happy, is because chaparral plants did not like to be flooded. So it took me a few trials to actually figure that out. These are some of the other pictures that we can see here, so you can notice how the root systems are really severely degraded. And so you can see some of the control plants, also the root system was a little bit rotted, but I think that's because we flooded the plants. But as you can see, there's a lot less root system in the infected plants with Erydiction and Salvia in this case. Now, we decided to repeat the trial because we didn't like how the controls were looking and we wanted to compare more in severity. So what we did, we inoculated now in these tubes. I grew all these plants from seed. That was a lot of fun. And we put these little wands and we kept the soil at a field capacity. relatively humid, so the Phytophthora will still like it and the plants won't be unhappy. And they were all very happy growing. Until we started noticing that, in this case, chamise was very susceptible to this Phytophthora, Phytophthora multivora, which is another homophthalic species that produces oospores, and we're finding them in drier areas. They were very aggressive against chamise. As we can see here, the root system, basically it's missing, and this is just a matter of 4 weeks. The chamise kind of dried up, and you would like grab this plant and touch it a little bit, and it was crunchy. It was like dry. It was clearly dead. So one thing that we also wanted to do is see if we can see how aggressive the Phytophthora were with younger plants. In this case, we grew the plants from seed, and we took seedlings about like a month to 2 months old. In this case, it was salvia, and we had these little scintillation vials. We made a soil spore suspension. We pipetted it up and just filled it in here to this root system. And it's a very beautiful way to see the diversity and how different Phytophthora can be aggressive. But at the same time, we can have, instead of having a whole greenhouse, a whole bench of different plants, we can have this in all like a little, in the lab on a little bench. So it was a lot easier to test more plants and test the susceptibility of these native California plants. So remember the zoospores that we saw in the initial slide? This is another zoospore that's initiating its germination tube, and it's going to start infecting these small radicals. This is some of the photos and some of the symptoms. So we inoculated the plants, and then we started taking photos daily, and we scored the plants depending on the symptoms they were showing. So you can see in the 14 days, the plant again showed a lot of necrosis. The Phytophthora moved up the stem of the plant and started inclusively infecting the leaves. And our controls were, this is Eriogon fasciculum, California buckwheat. And the controls were really happy. We also did the same test for chamise. Okay, thank you. And then again, I wanted you to notice that multivora was again one of the most aggressive ones. These are what we call disease curves, in the sense that we see here the amount of days post-infection and our severity scale. And you can see multivora was just spiked up really fast. After day 5, it just went up. Another thing that we can evaluate thanks to the scintillation vials is that we can also evaluate how many new roots are produced in each of the isolates. No new roots were produced. Okay, I'm wrapping up. And Crassomira, for some reason, we noticed that it was not as aggressive as other Phytophthora. But again, multivora was, again, the most aggressive one. And to wrap up, this is my final slide. Again, I lied again, showed more list of species. I wanted to show the context of these Phytophthora that we tested. This is a paper that we published with Tyler. I don't know how many people know Tyler, but he was a postdoc in our lab. And we grabbed all the Phytophthora reports that were present in California, and we classified them as either belonging to agriculture, forest, horticulture, or restoration. And horticulture, where we also put nurseries. And I want you to notice that the Phytophthora that we tested, Crassomira, Cactorum, multivora, were all associated with either forest, nursery or horticulture, and restoration area. So these Phytophthora historically been associated with these contexts across California. So as a final take-home message, these Phytophthora were associated with nursery and restorations. Higher frequency was in riparian areas, higher frequency of resistant structures in upland areas, and dispersal was associated with OHV trails or waterways. At the end, all the Phytophthora we tested were able to cause diseases in all the chaparral plants, and chamise was highly susceptible towards Phytophthora multivora. And this is my thank you acknowledgement. So thank you so much.
Okay. Just feels a little somber. I'm sorry, it's going to be. And thinking of these results in regards to like the BMPs in the nurseries, where we kind of have controlled circumstances. So our principle of, like be careful when we're out there trying to care for the land. Folks who are going out to do field research or installation contractors, all of that, trying to keep your trucks and vehicles clean in doing that is just a whole nother layer of challenge. It's really hard. Okay, anyway, so to take us home, we are very honored to have Dave Rizzo here, professor and chair of plant pathology at UC Davis, where his research focuses on diseases of plants in natural ecosystems. He's done extensive work on one of the most infamous Phytophthora species, the one that causes sudden oat death, and has won like so many awards that it would really take a lot of precious time for me to list them all. And I don't want to take away from his time of sharing all his valuable information with us today. So please welcome me. Please join me in welcoming Dave Rizzo. Thank you.
I need my glasses to figure out where I have to hit the button. All right, well, thank you very much, Anna and Susan, for the invitation. It's been great to be here listening to the first 4 talks. A couple of things I've learned over the last couple of days. One is when you write an abstract 5 months in advance, and then when you come to actually put the talk together, you realize, all right, well, this is not a 15-minute talk, this is a 5-hour talk. So that's not going to happen. The other thing you learn is that when you go last in a session, everybody gives your talk for you. So I am happy to take questions right now. And honestly, they hit like all these points. So what I'd like to really do is just kind of give a few thoughts, because really I want to hear from the audience and hear comments and hear questions. So I am going to like blast through this talk. I should point out that, I put special thanks. Sebastian mentioned Tyler Bure, who was a graduate student and then a postdoc in the lab. Susan, Ted Swicky's been mentioned about 400,000 times over the last few talks, and a number of other folks, that a lot of this information comes from them. In fact, a lot of my bullet points I just basically stole from Susan Frankel and Tyler in a paper they recently published. So I have a lot of bullet points. I'm not going to read them all. I think everybody here knows how to read. So I'm just going to kind of give some broad overviews, and then really, I do want to hear people's thoughts, so I'm going to go fairly quickly. So the talks we've heard already, we started with Betty kind of talking about this, really giving a great case study out in the natural areas. And she hit a lot of the key topics that I wanted to talk about as far as what do you look for in the landscape. Then we shifted to the nurseries, the idea of prevention, but Mia also gave some great information on things, the transition from nurseries to natural ecosystem. And Sebastian just gave a great overview of a number of different Phytophthora. So, this slide here just kind of sums up a lot of that stuff. And when you start looking, particularly over the last 10 years or so, looking in restoration areas, looking in nurseries, there's been a ton of Phytophthora identified. And when you look at the 60+ species of Phytophthora, 20 years ago there wasn't even that many described species of Phytophthora. And so things have really changed. Many of these are undescribed that have recently been found in restoration areas, in nurseries. And, one of the things, and Sebastian kind of hit home on this, is we really know very little about the biology and ecology of many of these species. I mean, this is just a few, plants that were sampled in the Bay Area. Janelle knows this slide well. When you look at individual plants, one juncus with 2 species of Phytophthora, that mugwort with a whole pile just on a single plant. And so we have this pile of Phytophthora, and honestly, to tell you, we don't know the biology and the ecology of these. Some of them, as Sebastian mentioned, may not do anything. But we do know that occasionally these things do cause a lot of destruction. And these have been mentioned. Sudden oak death, millions of trees killed. Phytophthora cinnamomi is another really important one. This is clearly an introduced species in the California. It's probably been around for a very long time. This is Io manzaneza, same one that's at, Vine Hill. People mentioned it in Australia. So, when I put this talk together, a lot of these types of talks talk about, the basics, and then you go how to sample, and you end with management. I just kind of threw the management right up front, and it's been said multiple times. It is really, really hard once a Phytophthora is established. And I got to put more stuff on here. We could talk about this for an hour. I mean, we could look at removal of infected plants. Mia knows all about the heat treatment and stuff as she's like shaking her head here. Chemical treatments, sometimes they work, sometimes the phosphonates. We tested some other ones that they have potential, but again, it's really difficult. Moving these things from controlled areas to larger area is really difficult. They cost a lot of money. And so prevention, the things that were talked about in the 2 talks on the nurseries, I think are really, really important. So why would we want to survey places? Let's focus just on the nurseries. But I do think it's important to know what's there. And I think what Betty was talking about earlier, I mean, she gave a fabulous example and could have just given my talk for me. And the things that Sebastian talked about as well. For 20 years, 22 years now, Susan, with sudden oak death, I've been giving these talks about management of sudden oak death. And, I'm in a department that does agriculture. And in agriculture, the management goal is yield. The disease is something that impacts yield, but if the thing's not going to impact yield, we don't manage the disease. With conservation, as you've heard already here, and I'm sure through this entire week, some of the goals and ideals are really complex. And I think understanding the distribution of some of these phytophthora, whether it's setting baselines or knowing the area that you're going to restore already has phytophthora, I think all of these are really important. So I took some of these slides, again, from a paper that Susan Frankel and Tyler Burry wrote this summer. And again, I'm not going to hit all these bullet points because I want to get to the questions right away, is what do you do when you have to sample? Martine gave a great talk on, sampling and her ideas of sampling and doing those testings in a nursery situation. And you see the same sort of issues, questions come up when you're going to sample an area that has already been restored or areas that you want to restore. And so, I'm not going to come up here and say, this is the way you do it. A lot of these are very site-specific, and I probably should have moved bullet point 4 up a little further. It's that idea of what are your overall goals? Why are you doing the sampling? And what are your ultimate restoration, conservation goals? And phytophthora are tough to find. I started my career a long time ago working with forest diseases that you can walk through the forest and say, hey, there's oak root fungus. Hey, there's this. Phytophthora don't work that way. And it can be very, very difficult to find them. And Sebastian already hit that last one. These things they're very distributed, not randomly, but it can be very difficult to find them sometimes. And as restoration ecologists, these are all, I think, really obvious things to many of you as you're going through and deciding how to sample, how to determine impacts. When you look at California, obviously the vast majority of places have been impacted by humans at some point. And Plants have been moved around, but pathogens, insects, all these things have been moved around. All these things factor in to how you decide when you're looking at a landscape how you're going to sample. Soil has been brought up a whole bunch of time. I'm not going to really dwell on this too much. You've already seen that picture from Sebastian just a few minutes ago. And Betty, hit the home. Movement is downhill is a lot faster than uphill. And again, things that Sebastian, others have brought up, looking at riparian areas. If the goal is to just determine if Phytophthora is there, you want to sample to have the opportunity to, if it's there, you're going to get it. These are different goals than, say, what Sebastian's doing with his research and attempting to determine, ask other questions. So questions, I think, are really, really important. And water. And there's already some talks here, whether it's the riparian areas, or Mia talked about testing water ad nauseum with some of her things. So Phytophthora swimming spore stages. Now, you get different Phytophthora in streams than you do in soil. Phytophthora cinnamomi, for example, one of the most important ones. As far as I know, it is almost never detected in water. All the years that we have been sampling streams around the state, many other ones, it doesn't pop up in streams. Other ones do. So this idea of all these Phytophthora don't have the same biology or same ecology. And here's just some examples again, some sampling. I don't want to spend too much time on these. So that first few slides were really big picture stuff. All right, what do we do on the landscape? But what about looking at individual plants? And again, Phytophthora, although Sebastian gave a really good example of these things that have dormant propagules that you can potentially sample them from areas away from plants, Phytophthora are associated with plants. And that's where sampling is going to go. So you're going out in the field, which plants we're going to sample? Oftentimes, the best ones are the most symptomatic. And one of the things to think about when you're sampling is Phytophthora are very difficult to isolate from dead plants. So when you're looking at areas, again, this idea of edges or Phytophthora moving through, look for ones that are symptomatic, that just don't look right. I love that slide about kind of miscellaneous funkiness. I thought that was great. As I was like, I gotta write that down and use that term. You're all great ecologists. You spend time in the field. You know when something's off. One of the things that, somebody who worked in forest and we go into chaparral, some of those chaparral plants always look crappy, regardless of whether they're healthy or not. And so, but as you gain experience, you know that, all right, that crappy is different than that crappy. And I love the funkiness part. That I just, I thought that was fabulous. Again, look for plants that just seem a little off. I mean, these are just some examples here. I'm not going to go and read all these things in detail. And again, I just took this from a publication, but it's been brought up time and again, with this idea of making sure you have things that can be sterilized. I love Mia's thing of like, okay, you got to go home. You didn't bring the right trowel. And so as you work, avoiding spreading things yourself, so these are all important considerations. And again, soil type. When to sample is always a really difficult one. Phytophthora like water. So generally timing things during the rainy season or just after the rainy season. Mediterranean climates here seem to be really good for Phytophthora because of this kind of flipping back and forth between wet and dry. But this will also depend on certain species. I mean, we get certain species of Phytophthora at different times of year. So keep these sorts of things in mind out in the field, which is obviously a very different situation than in nurseries. Stream monitoring is another one. This is actually something we've been doing in our lab for close to 20 years now, primarily focused on Phytophthora ramorum, although we've gotten many, many other Phytophthora species. You know, people have talked about pear baits. We've used rhododendron baits. Throw them in the water, leave them for a little while, take them out, and plate them out. So we have actually monitored probably well over 200 streams over the years, primarily for Phytophthora ramorum, but we have picked up other ones, and it gives us a sense of what's in the water and what's not in the water. And for those of you who have streams going through restoration areas, this is another way of sampling things. And it gives you also a sense of how these things can move. We had a site up in northern Humboldt County where we baited Phytophthora ramorum from right near the coast, just north of Redwood National Park. And we worked our way backwards 25 miles till we found the actual source of the Phytophthora. Now, Phytophthora ramorum is a little bit on the unique side. However, you know, a lot of Phytophthora are moving through these waterways. You've seen lots of pictures of lousy-looking pears over the last one. And the comment I wanted to make there, I don't want to talk about actually, you know, the process, but you know, the ideas of false negatives and false positives. Phytophthora is really hard in these native ecosystems to pick up. So there are the potential for false negatives due to many different reasons. The sort of the distribution of Phytophthora in the landscape, the wrong time of year. So keep that in mind. One of the nice things, though, when you're doing culturing is it's rare that you ever have a false positive. That is one potential drawback of going to straight molecular techniques where you're just sampling soil and using molecular tools to identify organisms that are in the soil. It can be much more sensitive, but it can also potentially lead to false positives. So a lot of the sampling is to do both of those different things. And I think many of you already know this, that sample identification, California Department of Food and Agriculture, that's their website. I know, you know, CDFA was mentioned several times as far as giving samples. I won't put up any fee rates or anything. I'll leave that up to CDFA to say those sorts of things. But they are really good for identification. My department is currently, we're advertising and working to hire somebody to specifically work in nurseries, restoration areas. So I think that's going to be some really great options heading into the future. And Mia already showed this, so there are a lot of really, really good resources. And I did want to bring, and many of you have probably already seen this. I mean, a lot of the bullet points I mentioned, I shamelessly stole from, you know, a former person in my lab and Susan on their article here. But there was a number of really good articles in this issue there. So I'm from Philadelphia. I could talk really fast, so I am done. And I think the most important part's yet to come. So hopefully people will stick around, and I'll let Diana or Susan moderate. And I really would love to hear the questions and comments. So thank you.
Awesome. Okay, that's not one. Okay, thank you so much, Nick. Yay. I think that's working. Okay, good. Great. Can we just have another round of applause and gratitude for all of our speakers today? I do have to give a little shout out to my co-chair, Susan Frankel, who really made all this stuff happen. So thank you, Susan. I think that we are just going to open up questions for all of the speakers, which is going to kind of merge into the nursery CNPS talk. And is Steve here? Oh, hello, Steve. Good. I'm glad you're here. Okay, so Steve, who is in charge of the California Native CNPS Healthy Native Nursery Program as well, is here. So we have all sorts of experts in the room to discuss, answer questions, share experiences and traumas. Okay, good. So we have
So what a fantastic, horribly depressing, but great series of speakers. Thank you. And so I've been in native landscapes for a long time, written a couple books and stuff. And in the last 10 years, we've discovered that in suburban landscapes, one of our worst problems, and I brought this up to Mia, and I was very pleased with her response, is that we're actually associating mortality with Argentine ant infestations, and that the ants undoubtedly, without doubt, go into and excavate soil and nest in the roots, and they place hemiptera all over it, sucking insects all over it. And we believe through that process are inoculating pathogens from sick plants to healthy plants, because they're actually moving the hemiptera from one place to another, especially as the plant dies, okay? And you guys are going to an amazing, unbelievable Superman effort to develop these, white room super sanitary hygienic protocols. And my frustration was still seeing that no one was really talking about this possibility that these ants, which are ubiquitous, could actually be a vector because of their propensity to want to nest in the root balls. And they'll bring in the root aphids and the soft scale, and and you'll pop a root ball and it'll be covered in ants, and they'll start flowing down your arm. And so I guess for Mia, because you really excited me, because you said, oh, we're doing stuff for Argentine ants, and we've got an expert on Argentine ants. So yeah, I'm kind of really curious what's going on with that, because I think it's a vector that nobody's really addressing.
Yeah, I'd love to hear what Mia's doing about it, and then I'd love to hear some pathologists weigh in on how they are as vectors.
So my disclaimer is that I am a botanist and I do all the planning and design and construction oversight. I do not actually run the nursery. So the exact details of, and because my boss did her whole PhD on Argentine ants, I just let them deal with it. But there's I think tanglefoot they put on all of the benches, and then there's also some sort of there's a physical barrier of sorts, and then we do test for Argentine ants. And then as far as vectors in the nursery, there's all kinds of things. We have turkeys flying in. So there's birds, we're never, the goal, and what I tell people, the goal is, we are not a lab. We're not trying to create a sterile environment. And the goal is that is not the goal. The goal is to lower the risk to the best extent possible. And so you can what if forever, and there's always going to be possible pathways of infection, but we are addressing the Argentine ants because there's things that you can do that's actually pretty easy to make sure that you're not introducing them into the sites.
I'm glad you guys at least are kind of recognizing it, because they go right into the root ball, right?
Yeah.
That's very encouraging.
Good.
Yeah, in addition to all the other things that Argentine ants can do to native ants, we're really trying to keep them out. Vector-wise, any input from pathologists in regards to?
Yeah, when you asked that question, Susan leaned over and said, good luck answering that question. So, there's really not much evidence that Phytophthora have vectors like many other fungi do. Their spores are generally not geared toward being vectors. And, you know, it's pretty funny, Mia mentioned turkeys. I mean, people in the early days of sudden oak death actually tested that, you know, had frozen turkey feet and stuck them in cultures and stuff. Now, that said, Phytophthora palmivora in cacao, bringing spores up into the trees. So that's probably the closest I've seen. However, creating wounds, stressing out plants certainly can lead to more infection. So if I had to pick a role, and it seems to me to be an important one, it's through that, creating small wounds, creating stress on plants, rather than the physical movement, unless they're moving soil. And that's where you generally see something like that.
I appreciate your idea on that, because and there's other kinds of
Yeah.
you know, wilts and fungi and stuff that could be, they're like little typhoid Marys. You know?
Yeah, and you know, you look at the size of the sporangia and chlamydospores and stuff. When you think of insects that vector fungi, generally they have sticky spores and they're really small. If an insect is going to carry a sporangium, it's kind of like a football. You know, it would be like the Heisman Trophy kind of thing, where they're carrying this giant thing that's not much smaller than they are. So that's where it's difficult. However, I certainly am not going to dismiss the importance of these other organisms.
I just want to mention we've actually been able, in the last 10 years, to develop treatments that we're bringing Ceanothus back from the dead, we're bringing flannel bush back from the dead, and a lot of these plants that had a reputation for being difficult or short-lived turned out to be especially attractive to ants, like Milo, Ceanothus, and stuff. And when we treat them, all the problems, it's wonderful.
I just wanted to dovetail in on that stress. Wounds from the ants or potential of the presentation earlier today was talking about drought stress and increasing vulnerability to pathogens there. But I believe Matt's got a question.
I have a question for the second to last talk about the Angeles National Forest. And of all of those Phytophthora species that you found down south, and when you're able to culture them in your lab and put them in those kind of ideal conditions for the Phytophthora to thrive, there was clearly a lot of detrimental effects on the adenostoma and the eriogonum. But what sort of effects were you seeing in the field?
What do you mean by the effects in the field? In what sense?
Were you seeing widespread plant die-off?
That's something that, like what Dave mentioned, is down in the Angeles is very dry. So I would say 90% of the plants look crappy. So it's really hard to actually distinguish what's symptomatic or not. And what we did do, and I did not show because I avoided, again, showing more lists of species, we also, every time we sample a plant species, we try to put a health score to it. Very simplified, because we try to generalize among all these different species that we sampled. And we try to make a scale from 1 to 4, saying 0 to 25 was a 1, and the percentage I'm referring to, like the canopy affected, and then 25 to 50, and then 50 to 75, and then a dead plant. Interestingly enough, we found a larger diversity of Phytophthora associated with healthy plants. And as the health score increased, we found less and less amount of Phytophthora. But again, the Phytophthora that had oospores and Phytophthora that were more resistant had those resistant structures. So, which kind of makes sense, and what Dave was kind of mentioning is sometimes it's really hard to isolate Phytophthora from dead plants. So a lot of the times you want to aim for plants that are not 100% dead and not 100% alive, but in the middle, where you can start seeing some symptoms. But again, that's something, take it with a grain of salt, and that's some of the project that we're going to start now. We applied with Dave, again, for more National Fish and Wildlife Foundation funding, and we're going to focus more on plant health in those areas now that we know where the Phytophthora are. So I can get back to you in a couple years.
The other thing, I'll add, Pests wiki went down to the Angeles, also sampling, and a lot of the dead plants were associated in areas where the runoff was being poorly directed. So you have a...
Is that working? Here, you gotta just.
You know, where the water was running.
Okay. I do see a couple questions back there. I just wanted to, because we're officially transitioned into the healthy nursery, do you want to go for the questions? Okay, got it. Susan.
Thank you. This is directed at the nursery producers, and this is a really basic question. I'm a grower also, but I don't know the answer to it. When you make your own soil out of peat-based mix, is that peat that you get in bales, or is any other type of potting soil, are they sterilized before they go into their bags? It's a really basic question, but they should be, and I never read that they are on the packages.
Hi, my name is Elisa Shore, and I'm with the Parks Conservancy Golden Gate National Parks Nurseries. And from the research that we've done, they do not. The big packagers or purveyors don't spend that kind of resource on the material that they sell. We have asked some of the companies, and no one can guarantee that level of cleanliness, which is why heat treating is the gold standard before being used in any sort of propagation.
There's another question just right behind you, if you wouldn't mind just passing.
Hi. I have a couple of questions actually for two different speakers. One is nursery related. I was wondering if somebody could speak to water treatment. We use creek water is our source, but we ozonate. So I'm wondering if that is, as far as on the different levels of effectiveness for water treatment. So I'm wondering if someone could speak to that. And then to the UC Davis or Davis-based folks, I'm wondering about any detections of Phytophthora in that area and where that's, if so, where is it prevalent?
So as far as I know, you can ozonate, and that does work. When we were looking and designing and building our nursery, our engineers were just more familiar with UV systems, and so that's why we went that route. So I don't know that much about, although we're about to build a whole gigantic ozonation facility. So maybe talk to me in like 3 years, not for the nursery. So maybe talk to me in like 3 or 4 years. I'll know more about it.
Okay.
Coming to the Davis Phytophthora summary.
So what was the question about detections?
I guess I'm just wondering, I'm not really aware of there being at least SOD in like Yolo or Solano County. So I'm wondering what how worried do we, I know we have to be worried, but how worried do we have to be?
So there's plenty of Phytophthora, and what's interesting is the first paper ever published on Phytophthora on oaks was on the Davis campus in the mid-1970s. And I don't know how many people have been, I know Mia, she got a degree, has been on the Davis campus. If you look at the quad, it's ringed by giant cork oak trees. And in the mid-1970s, they installed the first sprinkler system, and those cork oak trees started to die back. And that's when they discovered there was Phytophthora, and they listed 3 different Phytophthora, and that's when they stopped irrigating the cork oaks, pulled back and put decomposed granite around, and those trees are mostly still alive. You still see lots of oaks dying on campus that are like smack in the middle of the lawn and they get watered. What's interesting about those Phytophthora, and we still find them, and Sebastian's done a lot of the identifications, is the names of those Phytophthora have changed. We have different species. So it shows that back 50 years ago, that what we saw, the names have changed, the diversity has changed. So there's plenty of different Phytophthora around in Yolo County. And it was mentioned, suburban areas. They're all over the place in these different areas. And many times, if you see trees dying in parks, particularly native oak trees and native plants that are overwatered, 9 times out of 10, it's either Phytophthora or armillaria, or oak root fungus, which are very common in these areas. So.
So if no one has a burning question right now, I do, which is kind of, because I don't know, I know many people in the room, and we've come a long way. We've come a really long way. But part of the goal and hope for the time with the nursery chatting, the healthy CNPS, healthy nursery thing, is to find out, to kind of talk about moving forward and priorities and problems and goals and things that we can keep working on as a community together. So does anyone, I mean, I have one in mind, but does anyone else have some? I have a couple in mind. But burning things that you're like, oh, this has been coming up in the face of this Phytophthora risk. Thank you, yes.
Oh. Thank you very much. Something that has been a recurring theme this entire conference has been fire risk. And I don't see a ton of literature on the relationship, I suppose, between wildfire and specifically Phytophthora vermorum, which is just, I was fascinated with it during a school project, so that's why I was looking. But I haven't looked that deeply for the other Phytophtheras. So I was just wondering what the experts in the room think about this wildfire risk and how that's going to affect Phytophthora invasion into new areas, how it's going to affect severity and current. Yeah.
Hand that back to him.
It is a complicated, and I pull my computer up and I'll show you a whole bunch of pictures. So we've been studying the relationship between Phytophthora and fire down in Big Sur now, going back to 2008. So we had set up a large plot network over about 80,000 hectares in 2006, and about a third of it burned in the basin fire, and then another fire in 2016. Then you had the Soberanes fire. Forgot about the chalk fire, and then you had the Dolan fire. And so we've been looking at those interactions. And we found a lot of different things, and said I could talk for a long time on the topic. Certainly, lots of dead trees adds fuel. But what we saw, specifically with sudden oak death, the sudden part when the trees are standing and brown, we saw in those areas we saw more crown fires. Where you had trees that died 10 years before and were on the ground, we saw a significant amount of soil damage. We also saw in areas that had some standing trees and some logs, that's where the worst impacts were with the fire. And so when you look at impacts and focus on several trees, bay laurel is going to burn up and die, no matter whether the sudden oak death was there or not. Tan oak along the same way. But the one that we saw the most impact on was redwood. So little redwoods are going to burn up, giant redwoods are going to be fine. But it was kind of the in-betweeners, the 2-foot diameter, 2.5 foot, where we saw 60% of mortality. Trees that should have survived these fires but did not. And that was, again, the combination of logs on the ground that impacted the soils and caused crown fire. So it was that mid-range there. We've also looked at, did the fire get rid of the pathogen? That would be really cool. The answer was in the short term, but anybody who's been out in burned areas know that it's not a uniform burn, and you'd have one tree that survived, and that's where the Phytophthora would then reinvade. But what was really interesting is, Sebastian showed the sprouting coming up, fairly quickly. And we started seeing symptoms on that and isolating Phytophthora. We're like, Vermorum survived, but it was not Vermorum. It was other Phytophthora that we didn't even know were there. Generally looking, Sebastian showed those oospore ones that were in the soil, had survived and then impacted some of the regeneration, the Phytophthora pseudosyringae that Betty showed on there. So so we learned things of this interaction. Now we're looking at much longer term. is Phytophthora contributing to some of these rapid burns? And then how does that impact regeneration? In fact, we're actually using this plot network to almost get away from sudden oak death and looking at ceanothus and conversion of redwood forest to chaparral, which we've seen in areas in Big Sur. So it's a great question. We have a lot of papers, and I could probably talk for hours on this, so I'm going to shut up.
Whew, okay. Delia.
I have a nursery question. Does anyone, when you're doing pair testing, you're doing a flat, do you ever take plants that you maybe don't want and put something that is really infected in it and do your pair testing to see if your pair testing method is working? Which would mean, do you have a positive control?
We have never done that at our nursery, like sensitivity testing. We kind of rely on the fact that Phytosphere has done a lot of that. And we rely on the fact that we have gotten positives in the past, so we assume that, the technique is working relatively well.
Well, what he told us is that we need to do it 2 or 3 times to really get a 90% positive, negative rate. That you have to repeat again. Like the first time, then go through 60%. Second time goes up a little better. You have to do it like 3 times to get something you're really sure about.
Yeah, I guess we've been relying on the sensitivity test that other entities and nurseries have done and just following their same methods. I'm not sure if Mia has another response.
We have not purposefully brought Phytophthora anywhere near our nursery ever. Ever. And we won't. I'm sure of it.
But Ted really has quite a lot, and this is actually one of the reasons that I think it's I am, sorry, hi. But Ted has a lot. So he's done, a lot of refining on the sensitivity of the method, which is why sort of sample size and the calibration, and why it's also really important for us all to do it the same way with each other, so our results are more robust. And it is a funny experience when you get your first positive, because you're like, it's working, but oh no. So it's a little bit of a roller coaster there.
Hello, so I'm Alejandra from previously Rancho Santa Ana Botanic Garden. We do that, mostly because we want to be sure that when we're testing, our procedures are correct. And what we use as our positive controls are buy-ins. So we as restoration don't buy in, but retail does. So that's usually our positive control. And so we test kind of quarterly, and we get those positives. So then we're like, if our plants are testing negative, we're a little bit more confident that they are negative because we are still, getting the positives from the other plants.
What did you say, buy-ins?
Yeah, so from retail nurseries, like bulk retail.
Buy plants.
Yeah.
Another question.
Okay, I know that we're getting close to cocktail hour, so we'll take just two quick. Okay.
I'd love to see your risk factors. How do you do your risk factors? I think that's such a great way to decide what you're going to test and how often. Do you have a list and all the species that you think are more susceptible and that kind of thing?
Yeah, I love that risk factor that Martine added. And maybe you can share that with
You might want to
connect them.
Yeah, I think a lot of the risk factors are things that are pretty intuitive, that a lot of people are already following, like symptomatic and things that have been there a long time. And I'm very curious about what other people feel like the risk factors are too. And I'd be happy to share the ones that we're using in some way. I'm not sure what way. But yeah.
Maybe on the CAN group listserv, we can have a conversation about people's different risk factors. Yes.
You have to wrap it up because we got to set up for dinner yet.
Oh, okay, sorry.
Okay, what can we do about the areas that have been infected with Phytophthora already? Is there any restoration we could do to the soil that's been infected?
Okay, so that last question, just before you guys go, because I'm going to hook you up with someone to answer that question, but I just don't want you guys to walk out with like, ugh. So just think back on Jennifer Norris's presentation, and everything that has started as a movement starts with one person, and everybody in this room now is like a nucleus to send out the message of being careful out there in everything that we're doing. So we're going the right way. And thank you so much for caring. Okay, bye.